November 5, 1941, Washington, D.C. A rough pencil sketch crosses John Niedermair's desk at the Bureau of Ships, carrying with it the weight of an impossible equation that has already cost Britain her entire armoured force. How do you build a ship that needs deep draft to cross an ocean but shallow draft to drive onto a beach? How do you make 300 tons of steel float like a cork, then sink like an anchor, then float again, all while carrying 20 Sherman tanks through German artillery fire? The Royal Navy has one answer: impossible. Ships need either ocean-going stability or beach-landing capability. Physics doesn't allow both. But 43-year-old John Niedermair, technical director of preliminary ship design, sees water differently than admirals do. He knows that ballast isn't just dead weight. He understands that a ship's relationship with the sea can be negotiated, manipulated, controlled, and in exactly 3 days, his rough sketch will become the blueprint for 1,051 vessels that will determine whether D-Day succeeds or fails catastrophically. Because without his impossible design, every Sherman tank, every artillery piece, every medical supply truck required to liberate Europe will die in the surf at Normandy, too far from shore to matter, too close to German guns to survive. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The mahogany conference table in the Bureau of Ships' Washington headquarters bore the weight of America's most desperate logistical problem. British Admiralty representatives spread photographs across the polished surface, images that had crossed the Atlantic in diplomatic pouches marked urgent. Dunkirk beaches, May 1940. 338,000 Allied soldiers rescued by destroyers and fishing boats and pleasure yachts in history's most miraculous evacuation. And behind them, abandoned on French sand, every piece of heavy equipment the British Expeditionary Force had carried into battle. 600.35 tanks, 2,000 artillery pieces, 75,000 vehicles, 11,000 machine guns. The mathematical arithmetic of Britain's defeat, photographed by German reconnaissance aircraft and distributed as propaganda evidence of Allied incompetence. Prime Minister Winston Churchill understood what those photographs meant better than his generals. Britain had saved her army but lost her ability to return to Europe. Every future invasion would require landing tanks and artillery directly onto hostile beaches, because German forces now controlled every port from Norway to Spain. The ancient problem had killed more British soldiers than enemy bullets in every amphibious operation since Gallipoli. How to move 40-ton Churchill tanks from transport ship to inland assembly area when the enemy owns every dock, every crane, every loading facility on the continent. Churchill's memorandum to his Minister of Supply had been characteristically blunt. What is being done about designing and planning vessels to transport tanks across the sea for a British attack on enemy countries? These must be able to move 600 or 700 vehicles in one voyage and land them on the beach. The British had attempted interim solutions with the desperation of men who understood that delay meant defeat. 3 shallow-draft tankers built for Lake Maracaibo, Venezuela, vessels designed to pass over restrictive sandbars while carrying oil, had been requisitioned and converted. HMS Bachaquero, Misoa, and Tasajera received bow doors and 68-foot ramps during 1941 conversions that consumed 6 months and demonstrated the concept's viability while exposing its fatal limitations. The converted tankers could carry 22 25-ton tanks or 33 3-ton vehicles, along with 210 troops. They proved their worth during Operation Torch, the invasion of Algeria in November 1942, successfully delivering armour to beaches that conventional shipping could never service. But their bluff bows created such tremendous water resistance that maximum speed barely reached 8 knots, making them vulnerable to U-boat attack during Atlantic crossings and too slow for large-scale operations that required rapid force build-up. The British delegation arriving at the Bureau of Ships in November 1941 carried requirements that seemed designed to prove the impossibility of Churchill's vision. The vessel must carry at least 20 40-ton Churchill tanks. It must beach on a 1 in 50 gradient, the shallowest approach angle found on most European coastlines. It must possess sufficient range for Atlantic crossings, approximately 10,000 nautical miles without refueling. It must accommodate assembled landing craft tanks as deck cargo, creating a mothership capability that could transport smaller landing vessels across oceans they could never traverse independently. And most impossibly, it must reconcile the fundamental contradiction that had defeated every previous attempt at shore-to-shore amphibious shipping. Ocean stability required deep draft, at least 14 feet of keel below the waterline to prevent catastrophic rolling in Atlantic swells. Beach landing required shallow draft, less than 4 feet forward to approach shorelines without grounding on sandbars that extended hundreds of yards from typical invasion beaches. Naval architecture textbooks taught that these requirements were mutually exclusive. A ship was either ocean-going or beach-capable, never both. Attempting to build a vessel that combined both characteristics meant creating a compromise that would fail catastrophically at both missions, rolling over and sinking during Atlantic crossings or grounding hopelessly offshore during beach operations. John Niedermair possessed qualifications that separated him from the career naval officers who saw only impossibility in Churchill's requirements. The 43-year-old had graduated from Webb Institute of Naval Architecture and Marine Engineering in 1918, during the final months of the Great War, when America's urgent need for cargo vessels had created a generation of naval architects who learned to think creatively about ship design under impossible constraints. He had served in the Navy during World War I, understanding firsthand the operational realities that separated theoretical calculations from practical seamanship. 23 years with the Bureau of Ships had taught him to visualize hull forms and structural arrangements with precision that other engineers applied to blueprints. Since 1938, as head of the Bureau's preliminary design branch, he had directed the basic conceptual work for every naval vessel entering American service. January 22, 1944. Anzio, Italy. LST 62 drives through surf that glows with tracer fire, her bow doors ready to disgorge British infantry onto a beach that German intelligence never expected the Allies to reach. The ballast system that John Niedermair sketched in 3 days is about to face its most brutal test, not from a single day of combat, but from months of sustained operations that will push his design beyond every specification, beyond every safety margin, beyond the limits of what steel and engineering should be able to endure. The operation that Churchill called his Wildcat Landing would trap Allied forces in a coastal beachhead for 4 months, supplied entirely by LSTs, making repeated runs through waters where German U-boats and torpedo bombers hunted with methodical efficiency. The vessels that survived would prove Niedermair's genius. The vessels that didn't would reveal the terrible cost of amphibious warfare waged with ships too slow to evade and too lightly armored to absorb punishment. Winston Churchill's strategic vision for Anzio reflected his lifelong fascination with amphibious flanking, movements that could unhinge static defensive lines through aggressive maneuver. The Gustav Line, anchored on Monte Cassino, had stopped the Allied advance up the Italian peninsula with defensive positions that German engineers had spent months perfecting. Every frontal assault produced casualty lists that exceeded territorial gains, creating a World War I stalemate that consumed resources while delivering no strategic progress. An amphibious landing 70 miles behind German lines, 25 miles south of Rome, promised to cut enemy communications and force withdrawal from the Gustav Line to avoid encirclement. The concept was operationally brilliant. The execution would prove that brilliant concepts still fail when logistics cannot sustain them. 2 divisions, the 1st British and 3rd US, would land at Anzio on January 22, 1944, supported by LSTs that Churchill insisted could be temporarily diverted from Operation Overlord preparations without significantly delaying the cross-channel invasion. The Prime Minister's arguments revealed his characteristic impatience with what U.S. Secretary of War Henry Stimson described as a mind which revolts against the hard facts of logistics. Churchill noted that LST crews, already in the Mediterranean, were veterans of Sicily and Salerno, experienced professionals who didn't require the months of training that new crews assembling in Britain needed before they could safely operate the temperamental vessels. He dismissed concerns about maintaining sufficient LST capacity for Normandy as mere inconvenience, bureaucratic worrying that prioritized logistics tables over strategic opportunities. The Americans reluctantly agreed, understanding that denying Churchill would create political friction that might endanger the alliance itself. 56 LSTs, originally slotted for Operation Overlord, remained in the Mediterranean to support Anzio operations. Those vessels would become prisoners of Churchill's strategic miscalculation, trapped in an operational commitment that consumed them for months, while Allied planners in London watched their carefully calculated LST numbers dwindle toward levels that threatened to make D-Day impossible. The initial Anzio landing on January 22 achieved complete tactical surprise. German defenders caught entirely unprepared for an amphibious assault that Allied caution had seemed to rule out. LSTs drove onto beaches that morning, encountering minimal resistance, their bow ramps lowering onto Italian sand that seemed almost peaceful compared to the German-occupied Sicily shorelines, where every beach landing had been contested by machine gun fire and mortar bombardment. But the follow-up that should have exploited surprise never materialized. Allied commanders, traumatized by previous amphibious disasters, where aggressive inland advances had ended in encirclement and annihilation, prioritized, consolidating the beachhead over pushing, toward Rome. German reinforcements arrived faster than Allied intelligence had predicted possible, containing the landing force within a narrow coastal perimeter that transformed Churchill's Wildcat into what he bitterly described as a stranded whale. The LSTs that had delivered the initial assault force now faced a mission that Niedermair's design specifications had never contemplated. Shore to shore, delivery assumed relatively brief exposure to enemy fire during initial landing operations, followed by withdrawal to safe anchorages while ground forces advanced inland. Anzio offered no such luxury. The beachhead remained within range of German artillery for months, every LST approaching the coast running a gauntlet of 88mm guns that could penetrate their thin hull plating at ranges exceeding 3 miles. LST-62, a Royal Navy vessel built by Jefferson Boat and Machine Company in Indiana and commissioned in March 1943, became intimately familiar with this sustained exposure to danger. Between January and May 1944, she completed 13 round trips to Anzio, each voyage carrying supplies forward and evacuating wounded soldiers on the return passage. The accumulating stress of these operations pushed crew and vessel toward breaking points that peacetime testing could never have predicted. The night of February 13, 1944, demonstrated the unique dangers LSTs faced from friendly forces as well as enemies. LST-62 was returning from her 9th Anzio run, sailing through darkness toward Pozzuoli near Naples, when the impact came without warning. HMS LST-416, inbound for Anzio, had failed to detect the outbound vessel in the moonless night. The collision struck LST-62 amidships on the port side, opening a gaping hole at deck level well above the waterline. The damage could have been catastrophic had the impact occurred below the waterline, flooding compartments faster than pumps could evacuate them. The LST's flat-bottomed design, while essential for beach operations, made her dangerously unstable if flooded asymmetrically. Water accumulating on one side would create a list that accelerated as more water entered, potentially capsizing the vessel before crew could evacuate. But the collision damage remained above the waterline, contained by quick damage control work that extinguished electrical fires before they spread to fuel tanks or ammunition stores. The impact sparked insulation material lining the interior compartments, filling the affected section with choking smoke that threatened to overcome crew members before they could locate and extinguish the flames. Training that had seemed excessive during peacetime drills now proved its value, sailors responding with practiced efficiency that contained the fire within minutes. But the experience revealed a vulnerability that enemy forces would ruthlessly exploit. The thin hull plating adequate for resisting water pressure offered minimal protection against explosive weapons that could penetrate steel and detonate inside enclosed spaces filled with fuel, ammunition, and human beings. LST-62 spent 12 days in Naples, undergoing repairs that temporarily patched the collision damage without fully restoring structural integrity. She departed on February 27 for another Anzio run, making 4 more voyages before the beachhead was finally relieved in late May 1944. Her survival was remarkable but far from unique. Most LSTs operating at Anzio suffered some form of battle damage, testament to both their vulnerability and their unexpected resilience. The vessels that weren't as fortunate told a darker story about what happened when LSTs encountered weapons specifically designed to sink ships. On January 26, 1944, HMS LST 422 struck a mine off Anzio and sank with heavy casualties, the explosion rupturing multiple compartments faster than damage control could respond. Mines represented perhaps the most dangerous threat LSTs faced, explosive devices that attacked the most vulnerable area of the flat-bottomed hull and created flooding that overwhelmed ballast pumps designed for controlled operations rather than emergency response. February brought even more devastating losses that revealed the LST's complete vulnerability to submarine attack. HMS LST 418 was torpedoed on February 16 by German U-boat U-230. The underwater explosion rupturing hull plates and flooding the tank deck within minutes. The crew had no chance to control the damage, the vessel sinking so rapidly that many sailors never made it topside before she went under. 5 days later, U-230 struck again, torpedoing HMS LST 305 and adding another vessel to the growing casualty list that was consuming Churchill's strategic reserve faster than shipyards could replace them. The same day that LST 305 went down, US LST 348 fell victim to German U-boat U-410, hit by 2 torpedoes that detonated in rapid succession. The double impact broke the vessel's back, literally snapping her spine as contradictory forces created bending moments that exceeded structural limits. Almost half the crew perished, trapped below decks when bulkheads collapsed or drowned when flooded compartments gave them no time to reach escape routes. The casualties from LST 348 exceeded losses from many destroyer sinkings, revealing that these slow-moving cargo vessels carried crews as large as combat warships, while possessing none of the armor or maneuverability that gave warships a fighting chance against submarines. British LST losses at Anzio ultimately exceeded American casualties, reflecting the Royal Navy's heavier commitment to sustaining what had begun as Churchill's personal strategic gamble. 2 cruisers, 3 destroyers, 3 LSTs, 1 landing craft infantry, and the hospital ship Street David represented naval losses that approached the scale of major fleet actions, except that these vessels died not in dramatic surface engagements, but in the grinding attrition of sustained logistics operations under constant enemy interdiction. The psychological toll on LST crews operating at Anzio exceeded the physical casualties, creating stress reactions that military medicine was only beginning to understand. Crewmen began arriving at Naples medical facilities suffering from what doctors called combat fatigue and shell shock, terms that attempted to describe the psychological breakdown produced by months of irritability, operating under conditions where death could arrive without warning from mines, torpedoes, or artillery shells that gave no opportunity for evasion or defense. Lieutenant John Wyman, commanding officer of LST 353, would later assert that of the 5 operations his ship participated in from North Africa to Normandy, it was the Anzio campaign that took the most out of us. The statement captured a truth about LST operations that differentiated them from conventional naval combat. Destroyers and cruisers engaged enemies in battles that lasted hours, intense action followed by periods of relative safety during transit or port calls. LSTs at Anzio faced sustained danger for months, every approach to the beachhead requiring crews to maintain combat readiness through journeys that lasted hours, while enemy forces chose the moment and method of attack. But the supplies got through. Medical equipment reached field hospitals that saved wounded soldiers' lives. Ammunition resupplied artillery batteries that broke up German counterattacks before they could overwhelm defensive positions. Food kept 2 divisions combat effective through months of siege warfare that would have starved them into surrender if LST operations had been suspended. The Anzio beachhead held not because of tactical brilliance or strategic genius, but because John Niedermair's ballast system kept working under conditions that should have rendered the vessels inoperable. The strategic consequences of the Anzio commitment rippled through Allied planning, with implications that threatened to unravel the entire schedule for Operation Overlord. When General Dwight Eisenhower arrived in Britain in January 1944 to assume his position as Supreme Allied Commander, he already understood that LST shortages posed the most critical bottleneck in invasion planning. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. British Major General Frederick Morgan, who had led the preliminary planning team, based all his calculations on a 3-division assault because he'd been told the combined chiefs of staff could provide sea lift for only 3 divisions. Eisenhower knew immediately that 3 divisions would be insufficient to break through Hitler's Atlantic Wall. He had used 7 divisions to invade Sicily, facing Italian and German defenders who lacked the time to complete the fortifications that now protected every metre of French coastline from Le Havre to Cherbourg. Expanding the Normandy assault to 5 divisions, the minimum force Eisenhower considered adequate, required securing additional LSTs from somewhere in a global logistics system where every theatre commander was simultaneously demanding more shipping than existed. The solution should have been simple. Cancel Operation Anvil, the diversionary landing in southern France that was consuming LSTs in the Mediterranean, and redirect those vessels to Britain for Overlord. But the strategic situation was vastly more complicated than simple logistics arithmetic suggested. Joseph Stalin had expressed enthusiastic support for Anvil at the Tehran Conference in November-December 1943, viewing the southern landing as essential to dividing German defensive resources. American Army Chief of Staff George Marshall supported Anvil for sound military reasons, recognizing that a second landing would prevent German forces from concentrating their mobile reserves against the Normandy beachhead. Eisenhower proposed a complex shell game, moving LSTs between theaters and exchanging them for other amphibious vessels in combinations that might satisfy competing demands without actually creating additional shipping. Send 20 LSTs from the Mediterranean to Britain in exchange for 6 attack cargo ships. Send 26 LSTs from the Mediterranean in exchange for 26 new LSTs coming from American shipyards originally destined for Pacific operations. Every proposal generated objections from commanders who would lose vessels without receiving adequate replacements, creating deadlocks that consumed weeks of planning time while construction schedules for Overlord support facilities advanced toward dates that assumed LST availability. The Anzio commitment made every calculation more desperate. LSTs that should have been steaming toward Britain remained imprisoned in the Mediterranean, delivering supplies to Churchill's stranded whale, while Allied planners watched their Overlord shipping estimates decline toward problem. Numbers that couldn't support even the minimal 3-division assault that everyone agreed was inadequate. The vessels trapped at Anzio would eventually be released, but only after Operations Overlord had already launched with fewer LSTs than Eisenhower's staff considered minimally acceptable for mission success. By May 1944, as Allied forces finally broke out from Anzio and began advancing toward Rome, the LST shortage had forced postponement of Operation Overlord from May 1st to June 5th, buying additional weeks for shipyards to complete vessels and for crews to complete training. But even that delay couldn't fully resolve the shortage. The invasion would proceed with approximately 85% of the LST capacity that original planning had specified as necessary, accepting risk levels that made success dependent on German mistakes and Allied luck as much as superior resources. The final preparations for D-Day revealed how completely Allied strategy depended on John Niedermair's 3-day sketch, functioning flawlessly under the most demanding conditions imaginable. 2,073 LSTs received assignment to Operation Overlord, these vessels representing 1,051 American-built ships plus additional British and Canadian construction. The number seemed overwhelming until planners calculated requirements for sustained operations. The initial assault on June 6th would require delivering 150,000 men, 10,000 vehicles, and 5,000 tons of supplies across 5 beaches spanning 60 miles of Norman coastline. But those initial deliveries represented merely the beginning of a logistics challenge that would only intensify after securing the beachheads. Within 48 hours, 130,000 additional troops and 17,000 more vehicles would come ashore. By D+4, daily supply requirements would reach 6,000 tons. By D+10, 9,000 tons daily. By D+16, 12,000 tons every single day without pause. Every ton of that material would flow through a logistics system that depended entirely on LSTs making repeated shore-to-shore deliveries under conditions where German artillery, Luftwaffe bombing, submarine attack, and simple North Atlantic weather could disrupt operations at any moment. The Allied invasion would succeed or fail based on whether Niedermair's ballast system, operating thousands of times across hundreds of vessels, could maintain the supply flow that kept 1.2 million American troops and their 250,000 vehicles combat effective. 12 LST companies received assignment to Omaha Beach, where German defensive positions represented the most formidable Atlantic Wall fortifications on the entire Norman coast. 7 companies would support Utah Beach, where American paratroopers required immediate resupply to maintain their precarious inland positions. Each LST carried 5,000 pounds of ammunition, medical supplies, and artillery shells that would determine whether 150,000 Allied soldiers survived their first day on Nazi-occupied soil or died in the surf under German machine gun fire. The vessels assigned to Overlord incorporated lessons learned from 2 years of Mediterranean operations. Sicily had revealed inadequacies in the original elevator system for moving vehicles between main deck and tank deck, creating bottlenecks that delayed unloading and kept LSTs exposed to enemy fire longer than necessary. Subsequent construction shifted to internal ramps that allowed continuous vehicle flow from upper deck to lower deck to beach, cutting unloading time nearly in half. Salerno and Anzio had demonstrated that LSTs required more extensive anti-aircraft armament than original specifications provided. Additional 40mm Bofors mounts and 20mm Oerlikon cannons bristled from every available position, transforming the vessels into bristling weapons platforms that still couldn't defeat determined air attack, but could make enemy pilots pay heavily for their targeting runs. The weight of additional armament and ammunition strained displacement calculations, forcing continuous attention to ballast adjustment to maintain proper trim. Corrosion control emerged as an ongoing battle that threatened to render LSTs inoperable through mechanical failure rather than enemy action. Mediterranean saltwater had proven more corrosive than North Atlantic conditions, exposing vulnerabilities in rotating machinery, electrical systems, and propulsion components that required constant maintenance to prevent failures. The ballast pumping system, essential to the entire LST concept, demanded particular attention. Pumps that failed during beach operations left vessels stranded at high tide, sitting targets for German artillery that could destroy them at leisure. The crews assembled for Overlord represented a mixture of veterans who had survived Sicily, Salerno, and Anzio, plus newly trained sailors who had never seen combat and would learn their profession under German fire. The veterans carried knowledge that couldn't be taught in training schools: how to beach an LST in heavy surf without broaching, how to maintain engine reliability during weeks of continuous operations without dry dock maintenance, how to identify submarine periscopes or torpedo wakes in time to sound alarms that might save the ship, how to live with fear that stretched for months rather than hours, the grinding psychological attrition of never knowing when death would arrive. The newly trained crews brought enthusiasm untainted by experience, still believing in their own invulnerability in ways that veterans had lost at Anzio. The combination would prove essential, veterans providing expertise, while newcomers provided the optimism that kept exhausted crews functioning when logic suggested that sustained LST operations under combat conditions exceeded human endurance limits. June 5, 1944, brought meteorological conditions that nearly cancelled the largest amphibious operation in military history. General Eisenhower faced weather predictions that violated every assumption about acceptable invasion conditions. Storms in the English Channel threatened to swamp conventional landing craft. Winds would scatter paratrooper formations beyond any hope of achieving unit cohesion. Seas exceeded every safety protocol for amphibious operations, creating conditions that even the most experienced naval officers considered suicidal for invasion attempt. But delaying the invasion meant losing tidal conditions that wouldn't recur for weeks, during which German intelligence might penetrate Allied security and discover the invasion target. German reinforcements might strengthen Atlantic Wall defenses beyond even the expanded 5-division assault forces' capability to penetrate. Eisenhower made the decision that would define his legacy, ordering Operation Overlord to proceed despite weather that suggested catastrophe was more likely than victory. Hour arrived at 6:30 a.m. On June 6th, the first wave of assault troops hitting Normandy beaches through surf that challenged every assumption about amphibious warfare feasibility. Omaha Beach became a killing zone, where German machine gun fire created fields of fire that stretched from waterline to the bluffs above the beach, concrete bunkers housing weapons positioned to destroy any vehicle or soldier attempting to cross the open sand. Initial reports suggested that the Omaha assault had failed completely, units pinned on the beach, and taking casualties that would force withdrawal unless reinforcements and supplies could break the defensive deadlock. The LSTs followed 30 minutes behind assault waves, their diesel engines driving them across the English Channel through seas that tested every aspect of Niedermair's design. Ballasted, to maximum draft for ocean stability, the vessels wallowed through swells that broke over their bows, flooding forward compartments and creating the sickening rolling motion that left crews struggling with seasickness while simultaneously maintaining combat readiness. Tank crews embarked in the LSTs endured even worse conditions, trapped in the enclosed tank deck where ventilation systems struggled to provide breathable air while the vessel pitched and rolled through storm conditions. The transition from sea to land operations occurred under direct enemy fire as LSTs approached Normandy beaches through surf zones that German artillery had pre-registered for maximum destruction. Machine gun bullets sparked off steel hulls, while mortar shells exploded in fountains of sand and seawater that obscured visibility and tested driver navigation skills. The bow doors, massive steel structures that represented the most mechanically complex component of the entire LST design, had to open reliably, despite months of saltwater corrosion and the accumulated stress of dozens of previous operations. The ballast system faced its ultimate test during beach approaches, pumps evacuating thousands of tons of seawater from compartments throughout the hull, while maintaining trim that kept the bow elevated enough to drive onto the beach without grounding prematurely. Pump failure at this critical moment meant certain disaster, the LST grounding hundreds of yards offshore where her cargo would be unreachable and her crew trapped under German fire. The system that Niedermair had sketched in 3 days in November 1941 performed flawlessly through thousands of D-Day approaches. Mechanical reliability achieved through ingenious design and maintained through crews' exhaustive attention to maintenance details that separated functional equipment from catastrophic failures. The first 24 hours of Operation Overlord witnessed logistics performance that exceeded every theoretical projection despite weather that should have made operations impossible. LSTs moved 3,000 tons of critical supplies during the invasion's most vulnerable period, when German forces concentrated maximum firepower against beachheads that remained within artillery range. Traditional landing craft would have required artificial harbour construction before achieving comparable supply flow, a process consuming 6 months and leaving invasion forces dependent on equipment delivered across exposed beaches. Omaha Beach extracted the highest price, German defensive positions, creating casualties that approached 50% in some assault units during the first hours. But the supplies kept flowing. LSTs grounded themselves on sand, still littered with bodies and destroyed equipment, their bow ramps lowering to disgorge tanks and trucks that immediately began the grinding work of reducing German strongpoints that conventional infantry assault couldn't eliminate. Artillery. Pieces rolled directly from LST tank decks onto beaches where their presence provided the firepower necessary to suppress enemy positions that commanded the beachhead. Utah beach operations proceeded more smoothly, American paratroopers having disrupted German defensive coordination enough that beach defenses never achieved the murderous efficiency demonstrated at Omaha. LSTs delivering supplies to Utah encountered fewer casualties, but faced identical challenges, maintaining operations under fire while negotiating tides that could strand vessels if they miscalculated their beaching time relative to falling water levels. The week following D-Day demonstrated LST strategic importance as supply operations expanded to support 150,000 Allied troops advancing inland from their initial beachheads. 15,000 tons of ammunition, fuel, food, and replacement equipment moved through the amphibious supply system, while German forces attempted to contain Allied breakout operations. Each vessel completed multiple round trips between England and Normandy, some LSTs making 3 or 4 trips weekly as crews pushed beyond exhaustion to maintain delivery schedules that kept combat units supplied despite enemy interdiction efforts. The first 90 days of Normandy operations established unprecedented logistics statistics that would define amphibious warfare for subsequent decades. 340,000 tons of supplies flowed through the LST system, representing everything from individual rifle cartridges to complete artillery pieces that enabled Allied forces to advance beyond their initial beachheads. The tonnage figures reflected not just material movement, but strategic capability that allowed relatively modest invasion forces to defeat larger German defensive armies through superior supply efficiency. Then came the Great Storm of June 19th through 22nd that nearly accomplished what German forces had failed to achieve, severing Allied supply lines completely and isolating invasion forces from the resources required to sustain offensive operations. Meteorological conditions exceeded any previous recorded measurements for the Normandy coastline. Winds reached hurricane strength, gusting beyond 80 miles per hour and driving waves that demolished Mulberry A, the artificial harbour that military planners had considered essential for sustained supply operations. Traditional landing craft became unusable as the storm created surf conditions that violated every safety protocol for conventional vessel operations. Smaller craft attempting to make supply runs from offshore vessels to beaches swamped within minutes, their crews barely escaping before the vessels went under. The Mulberry, a destruction represented loss of capacity that conventional logistics planning suggested would halt Allied offensive operations until replacement facilities could be constructed, a process requiring weeks that would allow German forces to organize coordinated counterattacks against invasion forces trapped without adequate ammunition or fuel. LSTs continued operating throughout the 4-day tempest that threatened to sever Allied supply lines completely. Niedermair's stable hull configuration, the ballast system that adapted draft to changing conditions, and the reliable propulsion components enabled continued operations when weather eliminated every alternative supply method. The flat bottom that created such miserable rolling in moderate seas actually provided advantages in extreme conditions, allowing LSTs to ride over waves rather than cutting through them like conventional hulls that could broach catastrophically in storm-driven surf. The vessel's 6-wheel drive capability, originally specified to handle soft sand during beach operations, proved equally valuable handling terrain softened by constant rainfall that transformed Norman beaches into mud suitable for bog warfare rather than mechanized operations. Crews learned to adjust ballast continuously during storm approaches, compensating for wave action that threatened to push them sideways off their intended landing zones. The accumulated experience of 2 years' Mediterranean operations paid dividends as veteran LST commanders demonstrated techniques that kept their vessels operational under conditions that terrified inexperienced crews, certain that each wave would be their last. German forces had planned their defensive strategy around weather patterns that would periodically isolate Allied beachheads from offshore supply sources. Intelligence reports indicated that German commanders expected storms to create operational pauses, during which they could mass forces for counterattacks that would drive invasion forces back into the sea before reinforcements and supplies could restore Allied momentum. The June storm's timing seemed to validate German expectations about amphibious warfare vulnerabilities. 4 days of impossible weather that should have halted Allied operations completely. Yet LST operations continued uninterrupted. While conventional logistics systems failed completely, Niedermair's design kept functioning. German forces waiting for the operational pause that would allow coordinated counterattacks, instead faced Allied units that never ran out of ammunition, never lost their mobility, never experienced the supply disruptions that defensive planning had assumed would inevitably accompany extended storm conditions. The hidden crisis revealed the LST's most critical strategic value: operational flexibility that functioned regardless of weather conditions that traditionally suspended military operations. Combat effectiveness during the Normandy breakout period proved that logistics determined battlefield outcomes as decisively as firepower and tactical innovation. Allied forces advanced inland because their ammunition never ran out, their wounded received medical treatment, their equipment remained functional through consistent supply flow that German forces could not interdict. The LST system had transformed theoretical supply planning into practical strategic advantage that enabled military victory through superior engineering rather than superior numbers. By August 19, 1944, Paris was liberated, and German forces in France were in general retreat. The Atlantic Wall breached permanently, and Hitler's fortress Europe fatally compromised. The campaign that followed would carry Allied armies to the German border and ultimately to Berlin. But the decisive moment had been those first 90 days in Normandy, when LSTs proved that sustained amphibious operations could succeed against determined opposition under conditions that conventional wisdom had always considered impossible. May 8, 1945 arrived with German surrender documents signed in a schoolhouse in Reims, France, ending the European war that had consumed 6 years and 60 million lives. The final logistics tallies revealed numbers that military historians would study for decades, trying to understand how Allied forces had maintained such overwhelming supply advantage despite operating through ports that Germany had spent 4 years fortifying against exactly this contingency. LSTs had moved 550,000 tons of the 15,750,000 tons of Allied supplies delivered to European battlefields during the campaign. 1/3 of everything that enabled victory, from individual rifle cartridges to complete Sherman tanks, had travelled through the amphibious supply system that John Niedermair had created in 3 days during November 1941. The statistical achievement represented more than tonnage figures. Each pound of supplies delivered by LST had replaced conventional logistics methods that required artificial harbours, multiple vehicle transfers, and extended supply lines vulnerable to enemy interdiction. Traditional amphibious operations demanded 6-month harbour construction projects before achieving comparable supply flow rates, delays that would have allowed German forces to strengthen Atlantic Wall defences beyond Allied capability to penetrate successfully. Niedermair's ballast system had compressed that 6-month timeline to 0, enabling D-Day to proceed on schedules determined by tide tables and moonlight rather than construction timelines that gave enemies months of warning to prepare their defences. The hull design had proven seaworthy enough to cross the English Channel fully loaded under combat conditions, validating principles that conventional naval architecture had always considered impossible. The flat-bottom configuration with minimal keel had handled 15-foot seas while carrying maximum cargo loads, demonstrating hydrodynamic efficiency that traditional displacement hulls could never match for shore-to-shore operations. Niedermair's calculations about weight distribution and stability had saved thousands of lives by ensuring that fully loaded vessels remained controllable in surf conditions that would have swamped traditional amphibious equipment. The ballast system itself represented engineering genius that transcended its specific military application. The concept of variable draft achieved through controlled flooding and pumping would influence ship design for subsequent generations, from offshore oil platforms to modern ro-ro cargo vessels that required similar capability to adjust their relationship with water based on operational requirements. Niedermair had demonstrated that a ship's draft didn't have to be fixed characteristic, but could be dynamic, variable, adjusted continuously to optimize performance for changing conditions. The cost in LST losses provided sobering counterpoint to triumphant statistics about cargo delivered and missions completed. 26 LSTs were lost to enemy action during World War II, killed by torpedoes, mines, bombs, and artillery fire that penetrated their thin hulls and created catastrophic flooding faster than damage control could respond. 13 more were lost to accidents, storms, and groundings that exposed the vessel's vulnerability to forces beyond enemy weapons. Each loss represented not just a ship but a crew of 123 men who had volunteered to operate the most vulnerable vessels in the amphibious fleet. The relatively modest loss rate, less than 4% of vessels constructed, obscured the accumulated stress that destroyed LSTs without enemy intervention. Internal Navy assessments confirmed that beaching operations imposed structural damage that rendered vessels unseaworthy after approximately 10 landings. The flat bottom that allowed beach operations also concentrated stresses in ways that traditional hulls never experienced, creating fatigue cracks in welds and hull plates that propagated with each subsequent landing until structural failure became inevitable. LST 512 demonstrated this accumulated damage when she broke apart in a storm, years of beach landings having weakened her structure beyond the point where she could withstand even moderate weather. The vessel simply came apart at sea, hull plates separating from frames as welds that had held through dozens of combat operations finally surrendered to forces that had been accumulating since her first beaching. Dozens of other LSTs suffered similar fates, victims not of enemy action but of the inherent contradiction in Niedermair's design. You could build a ship that beached repeatedly, but you couldn't build one that did so indefinitely, without consequences. John Niedermair returned to his duties at the Bureau of Ships after the war, directing preliminary design work for the 8,000 ships that passed through his office during 3 decades of service. He received the Navy Distinguished Civilian Service Award for his role in LST design, along with the David Taylor Gold Medal in 1958, recognitions that acknowledged his contributions while providing no meaningful compensation for having changed the course of human history. He retired in 1958 and died in 1982 at age 88, his obituary noting his service, but providing little sense of how completely the war's outcome had depended on 3 days of inspired sketching in November 1941. The Korean War's outbreak in 1950 brought LSTs back to combat status for the Incheon landings in September 1950, where their amphibious capability again proved essential for establishing beachheads without port facilities. The vessels that had enabled D-Day success demonstrated continued relevance in different theaters against different enemies, validating design decisions made 9 years earlier by a naval architect who had ignored conventional wisdom about military vehicle limitations. Incheon proved that Niedermair's innovation transcended the specific circumstances that had prompted its creation, representing fundamental advancement in amphibious warfare capability rather than specialized solution for defeating Hitler's Atlantic Wall. Vietnam would see LSTs perform their final combat missions, aging vessels from World War II production, supplemented by newer designs that retained Niedermair's essential concepts while incorporating improved propulsion and materials. By 1973, the last operational World War II-era LSTs were being retired from service. Their useful lives extended far beyond original specifications through modifications and refits that kept the basic design functional for 3 decades of continuous operations. The mathematics were elegant in their simplicity. The execution required engineering genius that translated conceptual innovation into mechanical systems capable of functioning reliably under combat stress. The impact exceeded anything Niedermair could have imagined during those November 1941 days when he sketched the awkward-looking vessel that naval experts dismissed as impossible. Because sometimes the difference between victory and defeat, between democracy and tyranny, between survival and annihilation, comes down to one engineer's willingness to draw a ship that looks wrong to experienced eyes, but works perfectly when physics becomes more important than tradition. And sometimes that's exactly what the world needs to survive its darkest hours. Thank you for watching. For more detailed historical breakdowns, Check out the other videos on your screen now, and don't forget to subscribe.